Hello, calculus. This is an introduction to the chain rule. If you're on OneNote, we're going to skip the top of it. We're on 3.4, the chain rule. And we're going to jump down to the actual rule here. And so if you have a situation where you're taking the derivative and you have a composition of functions, so we have a function inside of a function, to take the derivative of that, we use this rule here where we take the derivative of the outside function, leaving that inner function alone, and then multiply that by the derivative of the inside function. And this can be used for if you have more than one function. Here we're just at a composition of two functions, but you can do that for 3, 4, or 5, or even 6 functions. So if you get that copied down, we're going to apply that to find the derivative of these functions where we have a function inside of the function. So I'm just going to kind of rewrite the chain rule up here. The derivative of a composition of functions, a function inside of a function. Take the derivative of the outside function, leave the inner function alone, times the derivative of the inner function. And maybe if I put this in a different color, that'll help. Okay. So this first example here, my outer function is the sine of x. So think of sine of x as your f of x function, and your inner function is 3x. So if I want to take the derivative, I first need to find the derivative of the outer function. The derivative of sine is cosine. Now you leave the inside function alone. So this 3x here stays as the input of that function. And then I need to multiply that by the derivative of the inner function, and the derivative of the function 3x is just 3. So this is like your f prime of g of x times g prime of x. Okay? And most of the time with trig, you kind of put the constant up front. So this is really just 3 times cosine of 3x. All right? Same idea here. My outer function is sine. My inner function is x squared. So if I'm going to use the chain rule, take the derivative of the outer function. The derivative of sine is cosine. Leave the inner function alone. So leave the x squared as is, and then multiply it by the derivative of that inner function, and the derivative of x squared is 2x. Okay? And that's it, and just more commonly, you'll write the 2x out in front. So this is just 2x times the cosine of x squared. All right, the derivative of cosine of x cubed, the outer function is cosine. So if I want to take the derivative of cosine, that's negative sine. So I'm going to take the derivative of the outer function, so the derivative of cosine is a negative sine. Leave that inner function alone. That inner function is 4x cubed, right? That's our g of x. And I need to multiply it by the derivative of g of x, which the derivative of the inner function is going to be 12x squared. So we had 12x squared times, negative 12x squared times sine of 4x cubed. All right? Now we have e to the 3x, so my outer function, my f function, is e to the x, and my inner function is 3x. So if I want to take the derivative of the outer function, derivative of e to anything is just e to that anything. In this case, that input, that g of x, we're leaving alone again. And then I need to multiply it by the derivative of that inner function. The derivative of 3x is just 3. And just like with sine, I'm going to just rewrite this as 3 times e to 3x. But again, this is our f prime of g of x times g prime of x. This is f prime of g of x times g prime of x. This is f prime of g of x times g prime of x. All right, this last one, I'm going to first rewrite this. This is equivalent to taking the derivative of x cubed plus 5x to the 1/2. So if I make that 1/2, I can now use the power rule when I do the derivative of the outer function, just so I can do the derivative now. So the outer function is something to the 1/2. So the derivative of that is going to be 1/2 that something to the 1/2 minus 1. So I'm just using the power rule there. So that's my f prime part. Now leave the inner function alone. The inner function is the x cubed plus 5x. And then we need to multiply that by the derivative of the inner function. So the derivative of x cubed plus 5x is 3x squared plus 5. All right. So that's the derivative. If I were to clean this up a little bit, I'm recognizing a negative exponent. So I'm going to bring that negative exponent to the denominator and make that a positive 1/2. This 3x squared plus 5 right there. And then this 1/2, I can rewrite that as 1/2, but I'm just going to write that as a 2 on the bottom. So that 2 is on the bottom with the negative exponent. So that is the derivative of that function. And again, this is that f prime of g of x times g prime of x. All right. So that's using the chain rule. Let's do a couple more examples. Here I have the function, the cube root of x squared minus 6x. Let's first rewrite this as x squared minus 6x to the 1/3, so we can write it as an exponent instead of with the radical. So now we use our chain rule here, and remember that's f prime of g of x times g prime of x. So the outer function is something to the 1/3, so the derivative of something to the 1/3 is 1/3 that's something to the 1/3 minus 1. 1/3 minus 1 is negative 2/3. Leave the inner function alone, that's x squared minus 6x, so that's that part. And then I need to multiply it by the derivative of the inside function, the derivative of 2x minus 6. Excuse me, the derivative of x squared minus 6x is 2x minus 6. Okay? And then just like I simplified the last one, the x squared minus 6x, I'm going to put that on the bottom so that the exponents become positive. The 6x, the 2x minus 6 comes on top. And the 1/3, that brings that 3 to the denominator. Okay. So that is the derivative. And lastly, we have this. This is actually going to be a situation where I have 3 functions. We have, we want to take the derivative of the sine squared of x cubed plus 4x plus 3. Let me just rewrite this function again so it's more clear what's going on. I'm squaring this sine function, so I'm taking the sine of x cubed plus 4x squared plus 3, and I am squaring that. That is what this notation is telling us. You multiply this thing by itself. So if you can recognize here, this something squared is the most outer function here. Then we have the secondary inner function, which is sine. And then we have this third and final inner function, which is this cubic polynomial x cubed plus 4x squared plus 3. So in this case, we have f of g of h of x. All right. So for functions like this, a mnemonic that another teacher told me is PTA, which is power, that's the outer function. Take that derivative first. Trig, that's the middle function. And inside of the trig function is what we call the argument. In this case, it's a polynomial. So if I want to take the derivative of this whole thing, I first got it, so I want to take the derivative of this whole thing. First, take the derivative of the outer function, which is something to the second power. So the power part is going to be 2 times that something to the first power times whatever the derivative of the inside stuff is. So that's the power part. The inner function stays the same, just like we've been doing. Times the derivative of the trig part. So the derivative of the inside function, so I got to take the derivative of the sine of x cubed plus 4x plus 3. So the derivative of sine is cosine of x cubed plus 4x squared plus 3. And then, so there's the trig part. We did the power part. Now I can take the derivative of the argument part. So the derivative of the x cubed plus 4x squared plus 3 part is going to be, let me just move this over. Uh, 3x squared is the derivative of that. The derivative of 4x squared is 8x. And the derivative of 3 is 0. And that's the derivative of the argument part. So PTA, power trig argument, the first part of the function is a power function. So the derivative of power function, something to the second power, is going to be 2 times that something to the first. And then what the chain rule says, we then multiply by the derivative of that inner function. So the derivative of sine of x cubed plus 4x squared plus 3 is what I did here. That itself, the sine function's derivative, I need another chain rule. So the derivative of sine is cosine. Leave the inside function alone. Actually, I should probably leave that x cubed right in purple. So that's the derivative of cosine. The derivative of sine is cosine. Leave the inside alone. Times the derivative of that inside, which is the 3x squared plus 8x. So if we take the derivative, that's what we get. I'm going to just bring this 2 out here. I'm bringing the 3x squared plus 8x out here. And then we have, because this is all to the first power, you don't really need to put a 1 there. But that's sine of x cubed plus 4x squared plus 3 times cosine of x cubed plus 4x squared plus 3. So that is how we take the derivative of that big function where there's kind of 3 derivatives in there. Anyways, hope you liked the video. Again, if you want to see more content like this, consider ringing the bell for notifications and subscribing. And this video was brought to you by Surfshark VPN.